So let's consider 3 examples of differential equations. The first one will be d squared y dx squared minus 6dy dx minus 9y is equal to sine of x. Another example, dx dt is equal to x times t to the power of 5. And the last one is rc times dvc dt plus vc is equal to vs. Now we have 3 differential equations. Are they exactly in this form? No, but I could move this to the other side of the equation to have an equals to 0. Same goes for this and same goes for this. So usually you'll find the model written like this, and you saw it here as well, but we can always rewrite it in this form. Now what I'd like to identify is well, what is the solution we're after? Because if we have an equation, we're looking for a solution. And we want to identify the independent variable and the dependent variable. Now, one trick is, if you see here, we see that we take the derivative with respect to x. And we're taking the derivative of y of x with respect to x. Well, here we're taking the second derivative and here is the first derivative. And if we have that, we know that our independent variable is equal to x, and our dependent variable, or our unknown function, it is an unknown function in y of x, which is then also the solution we're looking for. So if we solve this differential equation, we get a function y of x. Now here we see that we take the derivative with respect to t. So our independent variable will be t, and the solution we want is a function x of t. The last one here, we take the derivative with respect to t, and we're looking for the solution vct, and this is the equation of the voltage across a capacitor if we have a supply voltage in a circuit with a resistor and a capacitor. So we can see we can model all kinds of processes. This is, here we see an example in electronics, and here we see an example in mechanics, and many systems can be modeled using differential equations. Now we'll be looking at very specific types of differential equations. So to identify what differential equations we're dealing with, we will look at the different properties of that, which we'll do in the next part.